Hello, everyone. As you heard, my name is Christoph from Fraunhofer IPA in Stuttgart, Germany. And yeah, I'm going to tell you a bit about what we've been doing in the European Union about ROS industrial, ROS2 integration, and so on. And mainly I'm going to focus on our effort right now towards building a reference robot cell for ROS2. So that might also well be interesting for you guys here if you're interested in getting some hardware that we tested and that works in the cell to set something up there. But first of all, I wanted to start and give you a short introduction to Fraunhofer. So basically the organization that I'm employed at. So Fraunhofer is an applied research organization founded in 1949. And it's one of the biggest in the world. So we have 30,000 employees, roughly 76 institutes with a budget of 3.9 billion euros. So pretty big, but no worries. So we are only one institute in there. Yeah, and quite a big bunch of the operating budget is basically generated through contract research. So either with government or industries. So we also have quite a portfolio in terms of services for industrial customers. Fraunhofer IPA is only, as I said, only one institute of the 76. So we are based in Stuttgart, not in Munich, as the central of Fraunhofer, with roughly 82 million euros of budget per year. So at least in 2021, that was the case. And each year we do about 1,000 projects with industrial customers in different areas of interest. And we have roughly 1.2 thousand employees. Yeah. Also active in creating patents and publications. So yeah, that's basically what Fraunhofer IPA does. And in Fraunhofer IPA, we have the robotics department, from which I come from. That's roughly 70 employees. Also one of the biggest robotics research lab, I would say, in Europe. We have roughly 40 robots right now. That's going to increase in the near future. 8 teams that focus on different areas of robotics. So you can see that on the bottom. Picking, packing, welding, industrial service robotics, assistance robots, robot programming, software engineering, and yeah, assembly automation. And the latest addition is basically robot safety. With the budget in the realm of 10 million euros per year. Yeah, so that's short presentation of what we are doing at Fraunhofer IPA in general. And the institute itself has a pretty long history of supporting ROS, using ROS throughout the years. What happened here? Throughout the years. Basically, we as well had some people going over to Willow Garage in the early, in 2010 and 2009, I think, for these internships. And yeah, at that point of time, we were developing a service robot called CareRobot 3. And that was basically the first robot that we switched over to ROS, because we saw basically ROS is really a nice framework for service robots. And yeah, that went on. And then we started prototyping ROS Industrial with South Research Institute. I think we started with the European Consortium somewhere around 2014. Yeah, since then we've been developing a lot of technologies, been using ROS in many projects, and have also been very active in creating some spin-off companies based on ROS. Yeah. With some on top technology. So for example, Mogen Robotics, it's a company that sells the CareRobot technology. And we have DragonBot that was around simple robot programming that is now part of Keba Robotics, of Keba automation, sorry. And Node Robotics is our newest startup that is basically focusing on robot navigation. Yeah. These are some of the technologies that we develop with ROS. Let's see how that works. Yeah, so for example, one thing that we lately did was cabling. So looking into cabinet assembly and how you basically get the cables connected. So this is just an early prototype, but it already could take information from ECAD system and then do some cabling. You have basically, force-based assembly is one of our focus points. Navigation, you already saw, we had a startup ongoing there. Something new that we've been currently investigating is basically packing. So essentially, how do you, from a bunch of objects that you get, create the best packed box? So in the hope that at some point we don't all get something from Amazon that is packed like, I don't know, 98% air and the rest is the packer is what you actually want to get. Polishing, okay, with scan and plan, that's something we do in ROS Industrial all the time. We had a collaboration in the clinical area, healthcare area, commissioning, and lately as well, we've been investigating weeding. So basically some, we're now also starting to go into the agricultural area with ROS as well. And then let's see if I can switch to the next page, or if the computer is going to kill me because it's overloaded. Let's see. Perfect. Yeah. So now you saw everything that we do at Fraunhofer IPA, and now I'll just jump in and tell you about what we do now in terms of creating robot cells. So that effort all started with this AI Matters project that we recently won. In the end, as a goal there is to create some kind of testing and experimentation facility for automation and robotics. With the, let's say from our perspective, the idea behind it, okay, we just want to get people to be able to experiment with automation technology, new technologies such as ROS2. In total, this project has a funding of 60 million euros around Europe. So there will be 7 of these facilities in different countries in Europe. We're going to develop this kind of a joint service catalog for testing and experimentation in automation and robotics. So on the one side, experimentation means you just experiment with the new technology. So that's more for end users. And then we have the testing part, which is more for the technology developers that kind of want to know, okay, does my technology work in a certain area as I expected? Basically the goal there is to go towards some kind of standardized test and experimentation services in Europe. Project runtime is 5 years, and it's funded mainly by the European Union, and then per member state, basically 50% is funded by the member states. So it's kind of a global European effort going on there. What I'm going to talk about is mainly focused right now on the German node, but as well, we are trying to push that towards the other nodes that everyone will have, hopefully, ROS2 experimentation cells around Europe. In the German node, we have us, Fraunhofer IPA, plus we have this kind of a research production facility called Arena 2036. University Stuttgart is involved, and PTB, which is a German testing institute for physical devices, actually. And as I said, German node has 4 partners and is basically funded as well by the state of Baden-Württemberg, together with the European Union. We at Fraunhofer IPA have something like 6 million euros of budget, which will be investing 2.5 million into reference infrastructure, so building up some kind of testing and experimentation infrastructure that people can use to just experiment. Involved in the project from our side are different kind of technology areas. You see that on the right. So we have basically supply chain, image processing, data analysis, and algorithms, which are involved. And then basically you have a more or less robotics and automation part with stationary robotics, mobile robotics, and the manufacturing systems. Hardware is planned to be set up in this testing and experimentation manufacturing plant that we have there at Arena 2036. And we hope to be opening for service for customers in Q3 2024. Let's see if we can achieve that deadline. The initial layout or planning that we're doing for that facility is basically to have 2 test production lines with 2 robot cells involved. You see that on the over there, and for other robot cells, of which 2 will be collaborative and 2 will be closed. Then we'll have this kind of mobile robot experimentation area with a small storage area and so on to just be able to kind of make it possible for people to as well test mobile robots there. And okay, yeah, the whole thing is called AI matters. So in the end, what do we need? It's also computation power. So there will be also some kind of compute cluster with at least sufficient capacity to run everything that's right now available on the market. I'm not sure if we're going to be able to train like these very huge algorithms, but yeah, at least running should be possible. And as well, we will have this kind of a small vision lab for producing as well data for machine learning in the end. So we've split this up a bit into different kind of infrastructure items. And I think the interesting part here is mostly, okay, what kind of test beds will we have? So for robotics, we'll focus on manufacturing test beds. That's basically the production lines that we're planning there. And then we'll have a robot assembly test bed, which is something that you can put into the cells, and then you can do tests with robot assembly. We'll have as well robot behavior test beds, so that's basically measuring sensors that measure behavior of the robot, for example, accuracy or something similar could be the case. We plan the same thing actually for mobile robots. And finally, also test bed for robot welding. So that's the ones that we're going to start with, and we'll hopefully be have that set up until Q3 next year. But what do we actually need for having all these kind of test beds? So our goal is to have this kind of a standardized robot cell that we can put that stuff into. And for that, earlier this year, we started a small survey to capture what do people actually expect from robot cells if they use them. Okay, trying to build a cell that covers all is certainly not possible. So basically, we took the average of all the answers to just have something that most people can use. In total, we got now 24 responses. Not the world, but I think it already gives kind of an overview what people are expecting. So in the end, the answer for us was that we should focus on something like 10 kilograms of payload and a bit above 1 meters of reach. And the most wanted robot manufacturers in that survey were Universal Robots, ABB, and Fanuc. Not sure if we can do the Fanuc stuff though in ROS Twitter. And in terms of sensors, people were looking into mainly using RGBD sensors or post-hoc sensors. So that's basically the main sensors they were asking of us. Yeah, and effectors will be finger grippers and vacuum grippers, and then depending on the application, you need something special usually. Yeah. And in terms of peripherals, we got the answers that mostly Ethercard, CANopen, and digital IOs were common. I think CANopen is more a thing from the ROS world, I suppose, or maybe that's from our from the group that we asked actually. And then on the right, you see actually the application that the respondees were working with. So pick and place and assembly are the most common ones, and then you have a few other applications that are also usually that people were working with as well. So what we are going to focus on then in our first cells, so we will also buy a few other robots, but the first robots that we're going to focus on is these three actually, so ABB, IRB 130, 1300, UR10, and the HE10. So they all have kind of the payload that we are focusing on. Plus, they have ROS2 drivers, yay. And then as well for the cells, we'll also build in some PLCs. So there we have chosen these two because for PLC Next from Phoenix Contact, there's a driver, a bridge, ROS2 bridge ready. And Bosch Rexroll has as well the capability to run some stuff in a Docker image directly on the PLC, which also makes it easy to kind of create a bridge there. So that's basically the plan in terms of hardware. We're currently kind of prototyping the auto, so system integrator is going to build the cell for us, but we're currently kind of creating what do you call it in English, specification for the cell, I think, yeah. So what do we actually want to have in the cell? What kind of doors and what should be removable so that you can use it I probably don't have to go in detail here, but just so you can see. So one thing I think at least in Germany now is kind of a standard in these kind of research cells is that you have these welding tables with a 50 millimeters raster, which are super nice to remount things. But yeah, that's probably going to be in there as well. Yeah, and based on that, what are we going to offer? So I'm not telling you that for nothing. So in the end, what we're going to open source here is basically the CAD design for the reference cell that we're building. We're going to have the BOM as well, open source. So basically, people can just rebuild what we're developing here, and we're also going to provide working and tested container images with ROS2 software there. So that's basically our goal in terms of open source services. In terms of commercial services, as I said, okay, we have this bigger project on top of it, which is around testing and experimentation. So there we will have services for assembly, welding, general manufacturing, automation, and robot accuracy or robot behavior in general that people can use and ask us to perform or do themselves in those cells. And then finally, we also plan to offer to help people customize this reference design to their needs. So once we have it published, you're also welcome to just contact us if you like to build a cell and you like to use the reference design or adapt it to your purpose. Yeah, what's the timeline? So in the end, I think the first cells we're going to set up at the end of this year. Hopefully, depending on ordering times, right? You all know it's pretty hard these times with hardware. And we're planning to publish the first release of the software composition, so basically of the document images, somewhere around Q1 in 2024. But we also welcome, or we're also looking for a little bit of feedback. So maybe if you saw something here that you don't like, or we think, okay, you should do something different, just talk to me in the break and give me your input. I'm looking forward to it. Well, let me just check. How much time do I have left? 9 minutes. Okay, yeah, I get that. So that's basically around that project. I also brought a few news about other projects that we've been working on in Europe lately. So one of my favorite projects right now is ROS Open. So that's basically the redesign of the ROS Openstack that we had in ROS1. What we did there is actually we switched out the base layer, so there's a completely new CanOpen library that runs it. We took that from Lily, one of our ROS industrial members that basically maintains that. Super nice stack. It's written in C, so it's a bit more difficult to integrate, but I think later on we'll have the benefit of having a really, really stable stack that's running already in very many devices. Yeah, we are now closing onto the beta 2 release here. So we have now ROS2 control integration for CIA4Z3 devices. For those that don't know what CIA4Z2 is, it's motion controllers. So basically the profile for motion controllers. You see that on the right, so for example, that is the PILS PRBT robot. It's a 6-axis robot that basically has all the drives running on CanOpen. And yeah, there was a driver in ROS1, and we ported that now to this stack in ROS2. Works pretty nicely. Still having a few minor issues with vibrations at some times, but I think that's actually a real-time problem in the end. And yeah, it's running at 100 Hertz, the 6-axis, yeah, looking great. Yeah, and we're hoping to release this as a beta 2 release pretty soon. The only thing that's mainly missing right now is documentation. So that's what we're going to work on this summer, and then we'll have a nice release that people actually can use, hopefully. In terms of what's going on in the EU, I think Matt already mentioned that. So we are having the ROS Industrial Conference 2023 for once not in December. I'm super happy about that. Other people might not. It's going to be in Bordeaux, so in France. It's going to be good weather there. Very nice and shiny. A lot of nice wine to drink there. So if you want to come, there's also going to be a visit to the Cité du Vin, which is basically where they have a small museum and wine tasting and all this kind of stuff. And plus, it's co-located with ROSCON France. So if you speak French, There's also going to be a few English talks there, but if you speak French, it's I think also a good thing to attend there. And then there's also the RoboCup. I'm not sure if you're aware of it, but it's basically this big convention of competitions around robotics that mainly students attend to. So there's going to be quite some crowd around robotics there. So I think it's going to be a really nice event. And another thing that we've started up again is ROS meetups in Stuttgart in Germany. We're going to have the next one in July. So if anyone wants to fly over, you're welcome. It's going to be at Bosch headquarters in Renningen. So that's pretty interesting as well, I think, to see. So they have all these kind of robotics research going on there as well. Yeah, and that's all from my side. I think I stayed a bit under time here. But yeah, thank you very much. And if there's any questions, just ask or meet me later in the break.
Thank you, Christoph. Any questions for Christoph? You mentioned many. Oh,
Yeah. You mentioned a lot of different test beds and services for testing. Do you have defined test methods and test artifacts that you use for each of those components?
For a few years, for most not yet. It's part of the project, so it runs for 5 years. We actually have some kind of effort ongoing right now that goes into functional testing for robotics, not only in this project, but also in a few other projects to kind of set tests that you can run for certain functionality of robots to kind of make them comparable. Yeah, we're discussing a lot about collaborative robots themselves, but also something like bin picking or so, because I think there's a lot of things that are really hard to compare and to see what kind of solutions work best.
A lot of existing stuff, either in standards or otherwise, that I would love
Yeah.
to have you not reinvent the wheel.
Yeah, we're trying to do so.
maybe he'll stop in here.
There we go.
Yeah.
Nice.
Any other questions, for Christoph? Oh,
You say that one of the PLCs you're running for yourself. You say that now they will run Docker image.
Yeah, they're both.
Okay.
They're both. So it's for both. It's possible to directly run Docker image on top of them. So the PLC Next from Phoenix Contact has the capability of doing that. That one we actually already tested because we developed the driver with Phoenix Contact together. It's working pretty nice. I mean, it's dependent on what kind of CPU you have on the PLC. But yeah, so depending on the CPU you have, you can run pretty nice stuff on it already. Well, you need to do the communication with the soft PLC or with the PLC that they have running on it. You usually need this kind of layer software in your Docker container to communicate with it. But that's what you actually need. Yeah. And for example, for Phoenix Contact, there's basically a Docker image out there with driver installed, and then you can basically just hook it into your existing ROS system.
that's a nice approach. Excellent. Oh, one more.
In the robot that you showed, you had two collaborative ones.
Yeah, because we have collaborative cells and non-collaborative cells. Plus, in the end, we have different kind of, or we expect to have different kind of customers. So some that basically really target the high-speed automation, and some that target like collaborative settings where you don't need such high speeds and velocities. So then, yeah, collaborative robot is also okay.
Well, thank you, Christoph. He'll be floating around, right? So feel free to corner him and ask him additional tough questions. Thanks, Christoph. Thanks for coming up.